Hello everyone, I am Ahmed and welcome to my third video lecture. So, in my last video lecture, I told about the crystalline solids and amorphous solids in details. So today, I will start from crystal lattice. Crystal lattice or lattice. So, what do we mean by the term lattice? Lattice is the regular three-dimensional arrangement of points in space. It is the lattice. How? Okay, first of all, I will define the term, that is a regular three-dimensional arrangement of points in space is called your lattice. By the way, here the term point means atoms or molecules or ions. Okay, so regular three-dimensional arrangement of points, say these are the points. A regular three-dimensional arrangement, they are arranged in a definite pattern. So like this way they are arranged. Okay, you arrange like this way, but it should follow a pattern. Randomly you should not put these points. Okay, here you have seen the atoms or the points are placed in a pattern or arranged in a pattern. So the each point of the lattice, here it is called the lattice point or lattice sites. So these points are called lattice points or lattice sites. Lattice point or lattice site. And these points are atoms, molecules or ions, already I told. So from this lattice you can imagine one thing, that this lattice will give the smallest three-dimensional unit or structure. Will it give or not? Okay, let me try. So if I join these atoms and these atoms, okay, now join them, it gives a three-dimensional smallest unit. Yes or not? Three-dimensional smallest unit. This three-dimensional smallest unit is called your unit cell. So it will continue. So if you join the other units, other points, it will form another unit cell here. So like this way it will continue. If you join them, see, it forms another unit cell. Again, if you join them, it will form another unit cell. See, so like this way, it will continue. You can arrange them in three dimensions. Okay. So these are what? These are our unit cell. Okay. I will define here the term unit cell. So what is unit cell here? Unit cell. Here you write the smallest three-dimensional unit, the smallest three-dimensional unit which when repeated over and again through a distance, over and again through a distance in its own dimension in the various direction generates a complete lattice. Complete lattice called your unit cell. Okay, so here we have seen the regular arrangement of points in space is called your what? Lattice. So again, if we join the lattice points, and if we can make the smallest three-dimensional unit, okay, and these units if we arrange them, or here it is said that which can be repeated over and again through a distance in its own dimension. So if we repeat them in 3 dimensions, then it will form a lattice. and this smallest structure or smallest unit is called the unit cell. It is clear? So here the shape of the unit cell will depends on the arrangement of the atoms. If the arrangement atoms is not like this, suppose it is different, then the shape of the unit cell also will be different. So next our heading or topics will be about the unit cell. Okay, so types of unit cell. So next you put the heading, that is the types of unit cell. Unit cell can be classified into 4 depending on the arrangement of atoms. Okay, so here you write types of unit cell. The heading is types of unit cell. How many unit cells are there? So you write here based on arrangement of atoms. Based on arrangement of atoms or points, there are 4 types of unit cell. There are 4 types of unit cell. What are they? First, number 1 is called primitive unit cell. This is the one, primitive unit cell. Next, third number, it is called, second number, it is called your centered unit cell. Centered unit cell. So here you have got only 2, that is primitive unit cell is also called the simple unit cell. So simple unit cell or primitive unit cell 1, here the centered unit cell 2. So here I have written 4. That means the centered unit cell are again 3 types. The centered unit cell are again 3 types. What are they? One is body centered unit cell. Another is face centered unit cell. And last one is end centered unit cell. So I will define the term, that is primitive unit cell. So what is called the primitive unit cell? So primitive unit cell means here you will get only atoms at the corners. You will get the atoms only at the corners. So here you write primitive unit cell means atoms present only at corners. Atoms present only at corners. So if I make the unit cell, primitive unit cell like this, say this is the primitive unit cell. So here you can see the atoms only at the corners. So these are the atoms. So how many corners are there? There are total 8 corners. So you can see only at the corners. Okay. So this is our primitive unit cell. So what about the body centered unit cell? So body centered unit cell, the atoms present at the corners. So here I write atoms present at corners as well as at body center. So how? Here the body centered unit cell is like this. Say this is our unit cell. Okay. The atoms are there at the corners. It is fixed. Beyond this, there will be one atom at the body center. Okay. So this is our body centered unit cell. Again, the face centered unit cell. So face centered, you define this one. Face centered. So atoms present, here I will write the atoms present at corners. Atom present at corners as well as at the center. of all face as well as at the center of all face. Okay, so this is our face centered unit cell. So face centered unit cell is like this one. So here the atoms are there at the corners. So how many phases are there? You can see this is one phase, this is another phase, below one, top one. Okay, again back of this plane or board and in front of us. So there are total 6 phases are there. So atoms will be present at the center of these phases. One above, another is below. Total 6 phases. Now end-centered unit cell. So what is end-centered unit cell? So here the atoms present at the corners. So here we write atoms present at corners. Atoms present at corners as well as at any two, as well as at the center of any, as well as at the center, you write like this way, as well as at the center of any two opposite phases, as well as at the center of any two opposite phases. It is your end centered unit cell. Okay, so end centered unit cell is looking, you can guess this one, end centered unit cell. The atoms present at the corners, it is always true. Beyond that, the atoms present at the center of any two opposite phases. It shows any two opposite phase. Suppose you have chose this phase and this phase, it should be opposite. Okay, if you choose the top, then you must take another one as below, bottom. Okay, so it should be the opposite phase and the atoms will present at the center of this phase. So this is our end centered unit cell. Clear? You see here. So this is our what? This is our unit cell. What our unit cell? This is our primitive unit cell. Here you can see the atoms only present at the corners. Okay, this atom, this, here you see how many corners are there? Total 8 corners you can see here. Total 8 corners, 1, 2, 3, 4 and above 4. So total 8 corners are there. So here it is not the atoms. Okay, it is not the complete atom, it is the 1/8 part of the atoms. You will get later on. So just to imagine this one. So here we have got the atoms only at the corners. Okay, so here this is one phase, this is another phase, this is another phase. So like this way 6 phases are there. 1, 2, 3, 4, 5 and 6. So 6 phases are there. So in the phases there is no any atoms, you see. It is vacant. Okay. So next, body centered. The body centered is looking like this. So 8 corners are there. So you can see here the 8 atoms, 1, 2, 3, 4. So 8 corners you have seen here, you see. You see it. So 8 corners are there. 8 atoms are there. 1 atoms will be present at the body center. So this you see, it present at the center or at the body center of this unit cell. Next, another, that will be your face center, and face center looks face centered unit cell. It is like this. You can imagine here. So how many phases are there? Total 6 phases, and beyond the corner atoms, the atoms that presents at the body center, you can see here, not body center, face center, you can see. So this is one phase, 1 atoms is there, this is another atoms, this is another atoms. So like this way 6 atoms you can see that presents at the face center of this unit cell. Okay, and end center, just to think like this way, that any 2 atoms will be present at the opposite phases of a unit cell beyond the 8 corner atom. So we have got the types of unit cell based on the arrangement of atoms. Okay. So our next topics will be, just you take a screenshot. I am going to wrap this one. Take a screenshot. Okay. Taken. It is too hot. Okay, our next topics is cell parameter. Cell parameter. Cell parameter. Here you write a unit cell is characterized by 6 parameter. A unit cell is characterized by 6 parameter. How? Here you have got in mathematics, these are x-axis, this is y-axis, and this is z-axis. Okay. So just you draw a unit cell here. This is a types of unit cell. You can imagine it or think it. These are unit cell. 3-dimensional unit cell. It is something like this. 3-dimensional unit cell. So if you consider, this is the x-axis, this is y, and this is z. So these are what? These are the edges, no? It is also one edge, here also one edge, here also one edge. Okay, so 3 edges are there. So if these are the edges, so this length is called what? Edge length. It is edge length. It is also our edge length. Okay, so this edge length from here to here, this edge length you can consider it as A. From here to here, you can consider it as B, and from here to here you can consider it as C. So only edge length I am going to draw here. So this was our edge length. Okay, so it is called A, it is B, it is C. Okay, the axis or the edge that's coming towards you, you take that edge length as A, and just you take it as anticlockwise. After A, it should be B, then C. So this is our edge length A, B, C. So for any unit cell, there should be the 3 edge length A, B, and C. So here you see the angle between B and C, or the angle in front of A. This angle is called your alpha, and the angle between C and A or in front of B, this angle is called beta, and the angle in front of C or in between A and B, this angle is called your gamma. Alpha, beta, gamma. So we have got the 3 edge length and 3 angles. These angles are called the axial angle, and this edge length is also called the axial length or axial distance. So 3 axial distance and 3 angles, axial angles, are the 6 parameters. Count it: 1, 2, 3, 4, 5, 6. So total 6 parameters are there. So to know a unit cell, you should to know the parameter. So if we can study, or if we know the parameters, we can say the types of unit cell. So here I have written a unit cell is characterized by 6 parameters. Okay, written here. So you write something that is A, B, and C are axial length or distance. axial length or axial distance of unit cell, or we can call it as edge length. Edge length. Edge length. Clear? And here alpha, beta, gamma. Alpha, beta and gamma are simply axial angle. Axial angles. So total there are 6 parameters, 3 axial length and 3 axial angle. Okay. Note down it. Taken. Finish. So next our topics will be the types of unit cell based on the unit cell parameter. Based on unit cell parameter, so there are 7 unit cell or 7 crystal system. Okay, take. So next you put the heading, that is crystal system. Crystal system or unit cell based on unit cell parameter. Unit cell parameter based on unit cell parameter. So here I will write some crystal system. There are 7 crystal systems. So crystal system based on unit cell parameter. So there are total 7 crystal systems. So what are they? One is cubic. So here I will write, okay, you make a table here. So here I will write the crystal system. Crystal system. Here you write the edge length. Edge length. Edge length. And next here you write the axial angle. Axial angle. The first crystal system is something called cubic. Cubic. After that, tetragonal. After the orthorhombic. Orthorhombic. Monoclinic. Triclinic. Hexagonal and rhombohedral. Rhombohedral. Rhombohedral is also called trigonal. Trigonal. So you have got here total 7 types of crystal system or unit cell. 7 types of crystal system here. Cubic is something like this. You have got here all the edge length are same. Say this is our A. This is our A. This is B and this is C. You can observe or imagine it like this way. So this is our A, that the axis or the edge length that is coming toward us, toward you. See. So this is our A, this is B and this is B, this is C. So here all the edge length are same, equal for cubic. So here A equal to B equal to C. But the axial angle, here you can see the axial angle, this angle and this angle, all are same, all are equal and all are 90 degree. So here it is alpha is equal to beta is equal to gamma is equal to 90 degree. So tetragonal is something like this. So here two edge length will be same, any two edge length will be same, but third edge length will be different. So here you can see the two edge length, this one and this one, these two edge length are same, but this edge length is here, it is more than this two edge length. Okay, so here you can write the edge length, that is A and B will be same here. So here you can see here, this is the A, this is your B, and this is your C. Okay, A, B, C. So you can put like this way. So this is our A, it is coming towards you. Okay, so this is our A, I have written here, you see here, you see I have written here, this A, this is A, and this is B, here B I have written, and this one is your C. So A, B will be same here, A equal to B, but C is different here, so not equal to C. But here you can see one thing, the angle that means each angle is same here, that is 90 degree. This angle and this angle. So alpha, so this here it will be called as alpha. So alpha will be what? So in front of A will be, this is our alpha. Okay, so in front of A, this is our alpha, and this is our B. In front of B, this one, this is our beta, and gamma in front of C, this is our gamma. So here all are 90 degrees. So you can say that is alpha is equal to beta is equal to gamma is equal to 90 degree. Next come to orthorhombic. Orthorhombic where? Okay, got it. So this is our orthorhombic, like mesh box. This is our orthorhombic. So here you can see that is A, B and C, they are all different here. Here you can see A, B and C. Okay, you see this, it's come towards you, it's coming towards you. Okay, so this is your A, this A, you see the length, and this will be your B, you see the difference here, got or not difference? Okay, and this will be your C. So it will be here, the three edge length will be different. That means here A is not equal to B, is not equal to C. But one thing is that axial angles are same here again. You can see here, this is 90 degree, this is also 90 degree, and this is also 90 degree. So all are 90 degree here, that is alpha is equal to beta is equal to gamma is equal to 90 degree. Our next one is, that is monoclinic. In the monoclinic, there will be A is not equal to B is not equal to C. But here, that is alpha is equal to gamma is equal to 90 degree, but beta is not equal to 90 degree. How it is? A is not equal to B is not equal to C. A is not equal to B is not equal to C. Okay, it is something like this. It is not the mesh box. Here you can see the angle, you can see here. Okay, it is little, you can see here it is little tilted, no, like this way, not tilted, you can it becomes distorted, no, it should be like this, it is little, it is distorted, it gets distorted. Okay, you can imagine here all the edge length, that is A, B and C. So you can put like this way. So this is A, this is B and this is C. So A, B and C are different here. At the same time, alpha is equal to gamma is equal to 90 degree. The alpha, so this is A, that means this is your alpha. This B, this A, B. So B means here it is beta, and gamma will be this one. So here alpha and gamma, you can see here the alpha and gamma are going to be here 90 degree, but beta is not your 90 degree. So it will be not 90 degree. So it will be like this. So it will be not 90 degree. Okay. So it may be greater than 90 or less than 90. That means it is not equal to 90. So there is one tricks. So I will tell the tricks how to remember the axial length and the edge length. Sorry, axial angle and edge length of different 7 crystal system. You can remember it easily. Next come to triclinic. So triclinic, here all the edge length are different, A, B, C all are different here, and here the alpha is not equal to beta, is not equal to gamma, is not equal to 90 degree. Most uncommon here. It is the unique type of your crystal system, and it is something like this. Triclinic, it is something like this. Triclinic. Okay, you see here, it is your triclinic. Here A is not equal to B, is not equal to C. So this is your A. You see here how it's look. How it's look? You can put like this. Okay. So this is your A coming towards you, and this is your B, and this is your C. So you can imagine here, so all the edge length are different. You see, all are different here, and the angles are also going to be different. So this angle, and this angle all are different here. You can see here. Okay. So this is called your triclinic. Triclinic is most unique. Next come to hexagonal. In hexagonal, A equal to B but not equal to C. But here, that is alpha is equal to beta is equal to 90 degree, but gamma will be 120 degree. Your hexagonal is something like this. This is your hexagonal. Okay, you see, it is like hexagon. Hexagon means what? That is 6 corner, no? Here you can see it is hexagon. You have got the benzene like, so benzene is hexagonal structure, so hexagon it is. So it is the hexagonal. So hexagonal crystal, in hexagonal crystal A equal to B. See here it is your A, this is your B, and A and B are same. This length and this length are same here, but C is different. This is the C is different completely. So alpha is equal to beta is equal to 90 degree. So here in front of A, these are A, in front of A there will be what? There will be your alpha, and in front of B this will be your beta. So alpha and beta, here it is 90 degree. That means it is same. Alpha is equal to beta is equal to 90 degree, but gamma is not equal to 90 degree. That means 120 degree. So this gamma, it will be 120 degree. Next, rhombohedral. In rhombohedral, A is equal to B is equal to C, all are same here, but here alpha is equal to beta is equal to gamma but not equal to 90 degree. All the angles will be same, but beta will not be, it will not equal to 90 degree. So it is something like this rhombohedral. You can see here the rhombohedral. So here A, B, C. Okay, it is your A, it is your B, and it is your C. So just you put like this coming towards you. So this is A, this is B, and this is C. So A, B, C are going to be same here. So exactly you see here, it is little short. Okay, you just consider these are same here. A, B, and C all are same here. Here alpha equal to beta equal to gamma. This angle, and this angle will be same here. Okay, but this angle is 90 degree or what? It is not 90 degree. So the angles will not be 90 degree. So this is the information or the edge length and the axial length of 7 crystal system. Okay. Now how can you remember? How can you remember the edge length and axial angle? Edge length and axial angle. So I will give you one tricks. So the crystal system, 7 crystal system, and you should to remember this order. Okay, cubic, tetragonal, orthorhombic, monoclinic, triclinic, hexagonal, rhombohedral or trigonal. This order you should to keep it in mind. So if you keep it in mind, that how can you remember? So there you can make one mnemonics. So mnemonics will be like this, that is cubic you put here C, for cubic you put here C, and tetragonal you put here T, orthorhombic O, monoclinic M, triclinic T, hexagonal H, and rhombohedral R. So you can remember like this way, that is C term THR. C term THR. So suppose you consider that my name is C term THR. Okay. So you follow me and you tell that I have my class on YouTube, and this class will be taken by C term THR sir. Okay. So you can call me like this. So C term THR, C term THR, C term THR. C means cubic, tetragonal, orthorhombic, monoclinic, triclinic, hexagonal, rhombohedral. Clear? So now you see here the first and last for edge length. For edge length, first and last is going to be same here. A equal to B equal to C. Here also A equal to B equal to C. Second first, you can see here the second, that means the tetragonal. Here you can see there is A equal to B but not equal to C, and second last you take this one, A equal to B but not equal to C. So these two is going to be same here, and 3 remains. Remaining 3 will be completely different. That means A is not equal to B is not equal to C, A is not equal to B is not equal to C, A is not equal to B is not equal to C. So 3 remains. So 3 will be completely different. A is not equal to B is not equal to C. So for all of them they will follow this. A is not equal to B is not equal to C, A is not equal to B is not equal to C. Okay. So now come to the axial angle. So axial angle, these 3 are same. These 3 are same. That is alpha is equal to beta is equal to gamma is equal to 90 degree. These are same. Okay. Now come to the monoclinics. Here you have to remember this one. But I will give one tricks, and from these tricks you can remember this in your whole life. How? You can see here the monoclinic. This alpha is equal to gamma is equal to 90 degree, but beta is not equal to 90 degree. Okay. So here you see that is the monoclinic. Monoclinic means what? You can consider this the Modi or Prime Minister Modi. Monoclinic means Modi. So Modi said the Man Ki Baat. Modi said the Man Ki Baat. So Man Ki Baat विरोध पार्टी नहीं मानेगी, विरोध पार्टी नहीं मानेगी, सब लोग मानेगी, लेकिन विरोध पार्टी कभी नहीं मानेगी. So here the monoclinic, that means Modi Sarkar, alpha is equal to gamma. Alpha, gamma, or the if more angles, more axial, if there is more axial angles are there, okay, all they will follow. But Birod party like Congress will never follow their ideology or Man Ki Baat. Okay, so beta is not equal to 90 degree. Okay. Again, triclinic. Triclinic, I already said that it is the most uncommon or unique, you can say, the unique type of crystal system. It is completely different, so it is easy. That is, A is not equal to B is not equal to C. Here also, alpha is not equal to beta is not equal to gamma is not equal to 90 degree. Okay. Hexagonal, you can see A is equal to B. Already we have got the angle before A, in front of A was alpha, and angle in front of B was beta. So if the A is equal to B, then there must be alpha equal to beta. Again I will repeat, A equal to B. So in front of A we have got the axial angle, that is the alpha, and in front of B we have got the axial angle, that is beta. So if here it is A equal to B, there should be alpha equal to beta. So here it is alpha equal to beta is equal to 90 degree. Okay, clear? But not equal to C. C will be different, and in front of C we have got the axial angle, that is the gamma. So gamma it will be 120. Already we have got. Last is rhombohedral. So rhombohedral, A is equal to B is equal to C, it is same. Here also it is same, that is alpha is equal to beta is equal to gamma, but not equal to 90 degree. So this is your tricks, and you can remember like this way. So our already we have got here the types of crystal based on the cell parameter. The types of crystal, or we can say the types of unit cell based on cell parameter. Here we have got 7, and types of unit cell based on the arrangement of atoms we have got 4. That is the what we have got, that is the simple or primitive, body centered, face centered, and end centered. So here we have got 7. So now if we merge them together, so if we merge them together, so we will get 14 types of lattice. and that 14 types of lattice will call the Bravis lattice. Okay, so next heading you put, I will make here and I will rub this one. Okay, so here you just put, that is the possible variation. Okay, so next heading you put here 7 crystal system, atoms variation. 7 crystal system based on atoms variations. You put here just variations. So how many lattice will form if we merge them together? So here are the 7 crystal atoms variations. So here you see like cubic crystal or unit cell. The cubic crystal may have the atoms at the corners, it may have the atoms at the body center, or it may have the atoms at the face center or end center. Okay, so experimentally it is found that in cubic crystal system the atoms present at corners, that means all the crystal systems will have the corner atoms. Without corner atoms no unit cell will form. So this is just remember this one. So beyond the corner atoms, so if it presents at the corner atoms, then it will be simple unit cell. Okay, we call this simple cubic unit cell or primitive cubic unit cell. Finish. If the atoms beyond the corner atoms, if the atoms presents at the body center, then we will call it as the cubic body center unit cell. And if the atoms present at all the phases, then we will call the face centered cubic unit cell. And if the atoms presents any two opposite phase, suppose this phase and this phase, then we will call the end centered cubic unit cell. But experimentally it is found that cubic crystal or cubic unit cell are 3 types. One is primitive, body centered and face centered. So end centered atom it is not found. Okay, that means do not exist. So here I can write the possible variations, the cubic. So cubic system cubics will give the 3 types of crystal. What are they? Number 1, primitive. Number 2, body centered, and face centered. Primitive, body centered and face centered. Next, tetragonal. Experimentally it is found that the atoms present at the corner, so we call it the primitive and body centered, and face centered and end centered it is not found here. 2 types of unit cell or lattice presents at tetragonal. Okay, next orthorhombic 4 types of crystal, that is primitive, body center, face center and end center. And monoclinic, in monoclinic only two forms, one is primitive and another is end-centered. Primitive and end-centered. In triclinic, only one, that is your primitive. Primitive, only corner atoms are there. Hexagonal, it is mixed, but it is also we call the primitive. Primitive. Rhombohedral, it is also your primitive. Primitive or simple. Now you can, if you count this, the possible, okay, if you count all the lattice that form here we have got 3, here we have got 2, here, okay, I write in this sides, extend it, here I write the number of crystal or lattice. You can put number of crystal or lattice. So here we have got 3, here we have got 2, here we have got 4, here 2, 1, 1, 1, 2, 1, 1, 1. Okay. So if you count this, all the lattice here, that is 3 plus 2 5, 5 plus 4 9, 9 plus 2 11, 12, 13, 14. So total 14 lattices are present, or we can say exist in the crystal system. So these 14 lattices are called the Bravis lattice. 14 lattice we have got, 14 lattice. So you can write one thing, that is the based on atoms variation, based on atoms variations in 7 crystal system, we get 14 lattice known as Bravis lattice. Bravis lattices. 14 lattice known as Bravis lattices. Okay. So next, okay, so examples are there: cubic, tetragonal, orthorhombic, monoclinic. The examples already, that means that is given in your book, just you learn from that. So cubic like NaCl, tetragonal like your zinc blend. Okay, these are the examples. So I have not written here. So next, our effective number of atoms in a given unit cell. Suppose the unit cell is given and you are told to find the effective number of atoms or the rank of the atoms of that unit cell. Effective number of atoms, how many atoms will present in a given unit cell. Okay, so here we have got the 7 crystal. So out of this 7 crystal, only the cubic is important, that is included in your syllabus, and a little about hexagonal. So we will study only cubic and hexagonal, and others it is not included in your syllabus, but this much is important. Okay, whatever I told you, this much is important. So after that, next topics, that is our calculation, effective number of atoms of a given unit cell, that is the either it may be primitive cubic unit cell or body centered cubic unit cell or face centered cubic unit cell or hexagonal unit cell, primitive hexagonal unit cell. So put the heading, that is the effective number of atoms effective number of atoms. This effective number of atoms is also called rank. rank of atom, effective number of atoms or rank of atoms of a given unit cell. So effective number of atoms, it is represented by the capital Z. Effective number of atoms is represented by capital Z. Suppose the questions came, find the effective number of atoms, find the effective or rank, find the effective number of atoms in primitive cubic unit cell. Primitive cubic unit cell. So how you will calculate effective number of atoms? So before you understand this, so let me write one thing here. Here I have drawn one unit cell. See, this one type of unit cell. Okay, you see here. Say this is a types of unit cell. Just to consider this atom. Do you think these atoms contributes 100% to this unit cell? No, because in this sides there is another unit cell already I have drawn at the beginning, no, when I told about the lattice. So here you will get another unit cell, like this way you will get. You see here. So if you join them together, so here it will another unit cell, and at the back of this unit cell there is another unit cell. You can see, you can imagine like this way. This is also another unit cell. You can consider this one. So you see the atoms here, one atom is there. So this is one unit cell, this is another unit cell, this is another unit cell, this is another unit cell. So how many unit cell is there? 4. So that means if you take the half atoms, the half atoms will contribute to 4 unit cell, and above this there will be other half atoms. Okay, so these half atoms will contribute to another 4 unit cell. So totally you can imagine the one atom contributes only 1/8 part to each unit cell. Okay, so this atom will contribute only 1/8 part to each unit cell. It will not contribute itself, or 100% it will not contribute to a particular unit cell, because it is the corner atom. So corner atom contributes equally. It will contribute this one, it will contribute this one, this one, this one, above. Okay, like this way it will contribute to 8 unit cell. So its contribution will be 1/8. Clear? Now just to consider this one, this is a types of unit cell, and if you consider this is the body center unit cell. So corner atoms are there. We have got the corner atom of any cubes will contribute 1/8 part. It will contribute to this unit cell or any unit cell. It will contribute only 1/8 part. But what about the body center? It is present at the body. Can you think these atoms contributes to other unit cell? No. It contributes 100% to this unit cell. It contributes to only a unit cell. So its contribution will be 1. Its contribution will be 1. So corner atom will contribute 1/8 part, but the body center atom will contribute 1. Okay. But you think the phase center. Here I will tell you. The phase center. These are the phase atom. So this phase atom, so this one phase. In this phase, the another unit cell will be there. So one atom will contribute half to this unit cell and half to this unit cell. Okay, that means one atoms will contribute equally, half to one unit cell and half to this unit cell. So this here the face centered atom will contribute half to each unit cell. So face center will contribute half, body center will contribute 1, and end center will contribute 1/8 part. Here we think like this we think here. So this is what, here you have seen the 4 unit cell, no? I made it for you, for your better understanding. Okay, these are the balls. I cut it with a billet and I join it and I made the 4 different unit cell. Here you can see, imagine here, this is the half ball. I have taken the half ball, I cut it, it is the half ball, and you can imagine here, or you can visualize here, this is one unit cell, this is another unit cell, this is another, this is another. So 4 different unit cells are there, and these half atoms contributes equally. That means this half atom contributes 1/4 to this, 1/4 to this, 1/4 to this, and 1/4 to this. So if the half atoms contributes 1/4, then another half atoms is there above this unit cell. That means if you flap this half atom or half ball, so another ball will be there, another ball must be there. You consider this is another ball. You consider this is your another ball. It was your half ball, it is another half ball. Now it becomes a full ball. You consider atoms. So now this part will contribute to another unit cell, this part will contribute to another unit cell, this will contribute this unit cell, and this will contribute, the unit cell will present here, it will contribute to this. Got? So now can you think that one atoms, if that presents at the corner, it will contribute only 1/8 part. Okay, it will contribute only 1/8 part to an unit cell. Okay, here you can see here, this is our face centered unit cell. So if this is the face centered unit cell, so you see here the phase atom, so half only comes to this unit cell and another half it goes to another unit cell, because another unit cell will be there. Okay, will be there another unit cell. So here also there will be another unit cell, in this side another unit cell. So only half comes to this unit cell. So the formula to find or to calculate this, the formula is needed. Suppose here it is said that they find the effective number of atoms in primitive cubic unit cell. So Z is equal to, so just you think how many corners are there? Total there are 8 corners in primitive cubic unit cell, and each corner atom contributes 1/8 part. So I will write like this way, there are total 8 corner atoms, there are total 8 corners, and each atoms or each corner atom contributes 1/8 part to it. So here if you consider it, you will get only one atom, that is in primitive cubic unit cell. Similarly, for find the effective number of atoms in body centered cubic unit cell. Body centered cubic unit cell. By the way, this body centered cubic unit cell, it is called, that is BCC, short form BCC, that is body centered cubic unit cell. In body centered cubic unit cell also we have seen that there are 8 corner atoms. So each corner atoms will contribute 1/8 part, plus there is one body atom. Okay, so one body atom is there, it contributes 1, already I told. Right? You see here body centered atom, where it goes. Okay, you see this one here, you can imagine here, this is the body centered atom, it contributes itself. One atom is there, it contributes 100%. The contribution is 1 here. Here the contribution is 1/8 part, but here one atom is there, but its contribution is 1. So here you can, if you count it, then you will get 2 atoms. Similarly, if you calculate it, the face centered cubic unit cell, it is called FCC. In FCC, the effective number of atoms or rank of the atoms will be what? Corner atoms, it is same. Next here it is your body center. So how many, sorry, phase center, how many phase atoms are there? How many phases are there? Total 6 phases. But each phase atoms contributes half to an unit cell. So if you cancel it, if you cut it, then 3, 1 plus 3 is equal to 4. That means in phase centered cubic unit cell there are only 4 atoms. I told that primitive cubic unit cell has only 1 atoms. Primitive cubic unit cell has only 1 atoms. So if I tell how many atoms is there, you will tell 1 atoms. 1/8 part, 1/8 part plus 1/8 plus 1/8. If you add them together, see each corner atoms contributes 1/8 part. So it was a complete ball or atoms. To this unit cell it contributes only 1/8 part. It is also 1/8 part, 1/8 part. So it was a complete ball. So I have not taken a complete ball here. So only 1/8 part of a ball I took this one. This is also 1/8 part ball. This is the 1/8 part ball. So if you join them together, you will get only complete ball. Imagine this one. Just you think. So this is a ball. It is a ball. Okay. It was a complete ball. I cut it to equal piece. Okay, I cut it to equal pitch, in equal pitch. Again, I cut like this way, like cross. If you cross it in this direction, you will get 4 pieces. Here you will get 4 pieces. Also, here you will get 4 pieces. So total how many parts are there? Total 8 parts. So that means from one ball, you have, this part is 1/8 part of that ball. This is also 1/8 part. This is also 1/8 part, 1 part. Okay. So now if we join them. If we join them, okay, you see it here. So if I join it here, join it like this way, okay, it will not stick it here. Just to imagine. So if I put it here, so it will become this unit cell. Okay, so one ball was there. So if you cut the one balls, so from one ball you can find a complete unit cell, that is the primitive unit cell. Okay, so now next questions, that will be homework. You should to do that. Effective number of atoms in hexagonal unit cell. So what will be the effective number of atoms in hexagonal unit cell? In hexagonal unit cell, effective number of atoms. Okay, I will give the hints. Find it, the effective number of atoms in hexagonal unit cell. So this is the hexagonal unit cell. Hexagonal. So these atoms, this is the hexagonal, sorry. So consider this is the hexagonal unit cell. Okay, you consider this is the hexagonal unit cell, hexagon. And if you consider these atoms, this atom will contribute, these are corner atom. How many corner? Total there are 12 corner atoms. These are the corner atoms. Already hexagon you have seen. Hexagon already you have seen. This is our hexagon. These are hexagon. Let me see whether it continues or not. Okay, it continues. This is our hexagon. So how many corners are there? Total 8 corners. Sorry, 12 corners. 1, 2, 3, 4, 5, 6, and here 6 are there. Can you think the contribution of these atoms to this unit cell? Here you see you can make another hexagonal shape here and another here. If this angle is 120, then this angle will be 120 and this angle will be 120. So 120 plus 120 plus 120, it is 360. So half atoms, if you take the half atoms, the half atom contribution to this unit cell half atoms contribution to this unit cell will be 1 by 3. Here also 1 by 3. Here also 1 by 3. So here 1 by 3. These atoms, half atom. It is not full atom, because full atoms will be above to this unit cell. Another half atoms, it will contribute to 3 unit cell. Okay, with 2/3 to each unit cell. So if half atoms contribution to each unit cell is 1 by 3, then another half atoms contribution will also be 1 by 3 to an unit cell. So here the contribution 1 by 6 to each unit cell, that means it is the corner atom contribution. Again, there are 1 atoms above and 1 other atom below, that means 2 phases are there. This one phase, it is also another phase. The phases atom, we know the phase atoms always contributes half to the unit cell, because another unit cell will be there, and below it another unit cell will be there. So these atoms will not contribute whole to this unit cell, it will contribute only half to this unit cell, and it will contribute half to this unit cell. Okay, two phase atoms are there, and in the hexagon there are 3 body centered atoms are there. So if the atoms present at the body center, it will contribute whole to that unit cell. Say how many atoms are there total? 1 2 3 4 5 6. Another is at the middle. So put the 3 atoms and another 6 you put here. It forms a hexagonal unit cell or crystal. So here the phase atoms you have seen here, these are the phase, 2 phases are there, so phase atoms you have seen. So if another hexagon will be there above it, then these atoms will contribute equally, that means half to this unit cell and half to this. Similarly, if another unit cell is there, then this will contribute half to this and half to that, and these are the corner atoms. So these corner atoms contribution will be 1 by 6, so 12 corner atoms, and here you have got the 3 body centered atom. So body centered atoms will contribute whole to it. Okay, it will contribute, its contribution is, if there is 1 body centered atom, the contribution is 1, if 3, then contribution is 3. Okay, so these are last topics already we discussed, no times is there actually. So it is your homework, time is over. Okay, next we will discuss the packing efficiency, the packing in the crystal. Okay, and that will be most important. So again I will not say anything, so this is your homework, just you do it and show me